Okay, here we go. Well, you can see the answers in red right here, but I'll walk you through them real quick. All right, so let's see. The first one is we're supposed to construct some segment CD. So we'll make there's some segment CD right there. I'll just label the C and the D part. So that's C and that's D. And then it says, actually, I'm going to move D because it's going to be in the way, or the label of D. So D is right here. Okay, put a dot there for D. How about that? Okay, so that's your D. I don't like that. I'm going to label it a little bit differently. How about that? All right, now I'm satisfied. Okay. CDP is a right angle. Well, let's see. If it makes a right angle, so CDP, so D is in the middle and it's a right angle. Therefore, that also needs to be a right angle. And actually, let me redo that because that would be a line. That's not a perfect right angle, but you get the right idea. I'll do the magic of labeling. I'll make it or force it to be a right angle. There we go. And so the line that I just made, I don't know, let's call that line, how about we call it line L right there. And I need point P somewhere. It doesn't really matter where, but I'll put P on it somewhere. So line L is perpendicular to CD and goes on forever. And so that would form that right angle CDP. And so that would be every single point on line L except for point D. I mean, point D is on line CD. So there we go. That would be the answer to 2A. 2B, it says CPD is now a right angle. Well, they're trying to have you remember that one construction that we did, actually not construction, but that one theorem that said that if you have a segment, actually, I'm going to start with a circle. If you have a circle, I haven't drawn a circle in a while. There we go. So if you have a circle and a diameter, I should have drawn the diameter first, but I didn't. That's pretty good. I'll put a little dot on the center to indicate that's the center. And then I'll do this in a different color, say blue, that if you have some point P on that circle, and this is point C and this is point D, we have that one theorem. That's a horrible D, but you get the idea. We have that one theorem that says because angle P will now be an inscribed angle, that if I connect it to the ends of the diameter right there, it's always going to form a right angle. And so if I move point P anywhere around on that circle, I just get more right angles. And so what would be the locus of it? It would be a circle. Now notice, I'll do this in green. P could be anywhere on the circle. So it could be, I don't know, it could be right here. And so I'll call this P sub 2. How about that? So P sub 2. And I'll call that original one P sub 1. So I have 2 points P there. And I better do this in green. And if I connect point P to the diameter, then I will always form a right angle. Now, notice there, the impression there is I'm making a rectangle there. There is a rectangle there, but only if point P sub 2 is at a specific location. Just because I made 2 right angles here doesn't mean I'm going to draw this right here. Doesn't mean that this is a right angle right here. Right? It could be not. In this case, just by visual observation, it's not a right angle. But there is a point P sub 2 somewhere that would form that. So what is the locus of all points? That would be that circle that we just wrote there. We would just have to exclude point C and point D. And there are your 2 answers that you requested. All right, if you have any other problems, ask away and I will answer.